Hi everyone, now let's look at the triple integral in cylindrical coordinate. If you can refer to page 81 of your module. Okay, so this time we are going to use a cylindrical coordinate in order to determine the volume of a solid. Okay, so the main equation to calculate the volume of a solid is still this one. So this is the triple integrals. Here is 1, and here dv, it is going to be replaced by dz r dr d theta. So this one will be the representation, okay, by using the cylindrical coordinate. So let's look at one example. Page 81, exercise 2.23. So this is an exercise where you have to convert, okay, you have to convert the triple integral given in Cartesian coordinate, okay, dz dx dy. You have to convert it to r, phi and z. Okay, so r theta and z. R theta and z is the representation in cylindrical coordinate, and this is the representation in Cartesian coordinate. So we have to convert this one into this one in order to solve for these triple integrations. So first of all, let's look at the relationship between the x, y, z and also the r, theta and z. So this is the relationship between the x and also r, theta. Y will be equals to r sine theta, and if you square the x and add together with the y, you will get the r square. As for the z, it is still the same. Z is still the z. So first of all, let's examine, okay, the interval for the z. Okay, so based on this question, okay, it is said that the z is from 0 up to square root 16 minus x squared minus y squared. Okay, and for this one, x squared minus y squared, I will convert it to cylindrical coordinate by refer to this relationship. So it will be equivalent to 16 minus r squared. So imagine when you bracket this one, the negative you take up, so it will be x squared plus y squared. So you get this one, and you put the r squared here. And for the x, the interval is from 0 up to square root 4 minus y squared. So 4 minus y squared. Okay, and the dy is from 0 up to 2. Okay, so this one we already convert it to the cylindrical coordinate format, but these two, okay, we need to redraw it in a 2D diagram in order to know, okay, the region that is wanted by the questions. So this is the equation where it says that the x is equals to this one. So this equation, when we rewrite it, it will be an equation for a circle where the radius of the circle is 2. Okay, so I draw a circle here. Okay, I draw a circle here. And if according to this interval, it says that my x is from 0 up to the circle. So this is my x. So it will be from 0. So this straight line is a 0 up to the equation of the circle. Okay, so I shade this section. Okay, this section I shade it. And next we move on to the interval dy. It is said to be from 0 up to 2. So this is my y. Okay, y equals to 0 is this horizontal line, and when it says that the y is up to 2, okay, y is up to 2, 2 is here. Okay, so it means that the portion that is mentioned by this interval is this one. Okay, 0 up to 2. Of course, you can shade this section also. Okay, and at the end, you will only take the section that is overlapped by these two intervals. Okay, which is these sections. Okay, which is this section. So actually, these triple integrals, okay, want to refer to these sections. So we have to redefine the interval for this section by using cylindrical coordinate. In cylindrical coordinate, we are dealing with the r and also the theta, so and also the z. So just now we already defined the z, which will be from 0 up to this 16 minus r squared and square root. As for our r, okay, the radius of this region will always remain 2. So it will be from 0 up to 2. Okay, 0 up to 2. Okay, and for the theta, the angle is 0 up to 90 degrees, right? 0 up to 90 degrees. So it will be 0 up to pi over 2. Okay, so after that, let's look at the equation again. Here is a z, right? Okay, we're going to rewrite this triple integral in this way. Okay, z will remain, okay, because it is also a part of the cylindrical coordinate. We no need to do any conversion, just remain a z. So you have the dz. Okay, here for you to write the interval for the dz. R, remember r, dr and theta, they are like a package. Okay, don't miss the r. So for the dr, this one will be the interval for your r, okay, which we defined just now, and the theta will be from 0 up to 90 degrees. So you perform the integration as usual. This one will be r square, z square over 2, and you replace the value here. And for this section, okay, the dr, okay, you can press calculator to get the answer directly. Okay, this one you can press calculator, you will get your answer 14. And when you perform integration one more time, this one you can press calculator or you just multiply it. So you will get 7 pi, which is the solution for the triple integrals here, but you solve by using the cylindrical coordinate. Okay, let's look at one more example. So given here triple integrals, okay, represented in Cartesian coordinate. Okay, so first of all, let's look at their interval. dz is from this one until 1, and this one we can convert it to cylindrical coordinate. Okay, so this one x squared plus y squared will be equals to r squared. So your dz will be from r squared to 1, and your dy will be from 0 up to this one, 0 up to this one, okay, and your dx is from 0 up to 1. Okay, so like we tried previously, we have to confirm the region which is mentioned by this interval. So when we have y equals to this one, okay, this is equivalent to a circle equation where the radius of the circle is 1. So I draw a circle, radius is 1. Okay, according to this interval, my y will be from 0 up to the equation of the circle. So this is my y. Okay, my y0 is this line. Okay, y0 is this line. Okay, extend up to the equation of a circle. So I shade the whole region. Okay, the upper part whole region here. Next, we move on to the x interval. Okay, the x interval is said to be from 0 up to 1. So this is your x. x0 is this line. So from 0 up to 1, so it is actually mentioned this section. So again, this section is the section you need to find the you need to define in your triple integrals interval. Okay, so this section, it has the radius 1, right? Always 1. So it will be from 0 up to 1. And for the theta, again, it is the same, 90 degrees, 0 up to 90 degrees. Okay, so again, we put it into our triple integrals. Here, the inner part, okay, is x squared plus y squared. So we have to convert it to r squared also. Okay, so this is r squared, this is also r squared. So we put here dz, this is the interval for your z, interval for your r, and interval for your theta. So you can solve like usual. And for these second level intervals, second level integral, okay, you can press calculator to get answer 1/12. Okay, and continue press the calculator to get this one. Okay, so again I repeat, you must make sure you know how to use the calculator in order to get this one. Okay, next, okay, let's move on to page 82. Okay, exercise 2.25. So now we are going to use the triple integrals to find the volume of a solid. So the previous question here is actually just exercise, okay, warming up for you, okay, to convert this thing, okay, to cylindrical coordinate and then solve it. So in this question, you don't need to draw 3D a solid, okay, you just solve because it is not calculating the volume. It is just a normal question where you have to solve it. But for this one, you need to calculate the volume. So this question mentioned that you have to use the cylindrical coordinate to find the volume of the solid within the cylinder x squared plus y squared equals to 4, and between the plane z equals to 1 and y plus z equals to 5. Okay, so you have to find the volume which is bounded by cylinder and two planes. So first of all, I draw the plane. This is z equals to 1. It is a horizontal plane, so you don't need to draw. Okay, and for this one, it is a straight line when you draw it in 2D. Okay, intersection point will be 5 here. So when you extend it in 3D, so this one will be your plane. Okay, y plus z equals to 5. Okay, next you draw a cylinder, extend in the z direction. Okay, this is your cylinder. Okay, supposingly it is extend to infinity, positive infinity and negative infinity, but the question says that you only need to calculate the volume which is cut by this plane. Okay, z equals to 1 is this one. This is a plane. Okay, just imagine it is cut by z equals to 1 and sliced by this plane. This is this one. Okay, you just imagine this plane, it cut the cylinder, so this will be the solid. Okay, if you see I shade it, this one will be the solid that you need to find the volume. Okay, so this is the equation that you need to use, okay, when you choose the cylindrical coordinate system. Okay, so first of all, we need to define the interval for the dr and d theta. Okay, so here I choose the xy projection. Xy projection, it means you look at this solid from the top, okay, from the direction of the z. Okay, when you refer from the top, basically you see a circle. Okay, and this circle, it has the radius of 2, right? It has the radius of 2. Why I know it's 2 is here. Okay, the cylinder has a radius of 2. So for my r, okay, it will always be 0 up to 2, right? 0 up to 2, okay, no matter which point, 0 up to 2. And for my theta, it will be a complete circle, so the radius will be from 0 up to 2 pi, 0 up to 2 pi. And then for the dz interval, okay, you need to imagine yourself sitting inside this solid. When you refer down, you see the z is equals to 1, right? Okay, and when you refer up, okay, you see this plane. Okay, the surface has been cut by this plane, and the equation of this plane is this one. So z will be equals to 5 minus y. Here, 5 minus y. Okay, since we are going to solve by using the cylindrical coordinate, okay, so we have to convert the y, okay, into r sine theta. Okay, r sine theta. Okay, next I will plug in, okay, all the interval into the equation for volume, and remember here will be 1, okay, for volume. Z, this is the interval for z. Okay, remember the r, dr, d theta. This is the interval for r, and this is the interval for theta. Okay, so you solve it. Okay, and for this section, okay, you cannot press calculator directly because it has the theta. Okay, so you have to somehow do the integration manually. So when you need to integrate in respect to the r, you just keep this sine theta as constant. Okay, when you get this one, you just integrate it by pressing the calculator. and you can get this answer.